Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this superposition theorem, which is still in chapter 4, we're going to integrate with a dependent source. So, how to deal with a dependent source attached in one linear circuit. So, in our previous video, we already learned how to deal with only independent sources. Yes, you need to apply that, but if in a circuit that exists a dependent source, which is with the diamond shape here, then what should you do? You just keep the dependent source as it is and just maintain where it is, and you follow the rules for independent source, which is to turn on only one source at a time. Okay, why we cannot remove the dependent source? Because of the Vx there here. This is the unknown, unknown value that exists elsewhere in the circuit, which is coming from here in the middle. So if you remove this, that means you remove, if you turn off the dependent source, the current source here, you're going to remove the Vx, okay, that attached to this current source. So just keep as it is and apply the superposition theorem for independent source. Okay, so what is the steps? I will spell it here. Okay, so the steps is to maintain the dependent source and do not remove it. Second, to turn on only one independent source at a time. You can apply the previous rules in the last video we had. And then third, you can find the value of interest. For example, if you want to find Vx, then how many independent sources you have in the circuit? If let's say our circuit here is only two independent sources, so we have two steps. So Vx equal to Vx1 plus Vx2. Then if you want to find I, same here, only two independent sources, so you have I1 plus I2. So I put in a table form. Step number 1, you turn on the 10 volt, and for the 2 amps here, you turn off. And then step number 2, you turn on the 2 amps, and then you turn off this 10 volt. For dependent source, you maintain as it is. Okay, let's draw the circuit. Write down the aim. Maybe here we want to find Vx, then Vx1 plus Vx2. Okay, so to turn off the current source, you can, this is to turn on the 10 volt here. So to turn off the current source, you can open the circuit like this, or you just ignore this part. And where is that Vx? Vx is located at here, and you just put 1 because this is condition for number 1. So this is a plus, minus here. Why we put here? Because actually Vx is here, it's supposed to be here because of the ground here, as is there. And then what happened to the dependent source? Keep as it is. So you maintain this thing, and this one will become Vx1. Okay, for step number 2, you turn on the 2 amps. So how to turn off voltage source? You replace it with a short circuit here, and then maintain the dependent source. But remember to write down this as a Vx2 because this is our condition number 2. And then where is that Vx2? It's located at the upper part here. So all nodes here belongs to this Vx2. So I shall not draw this, but you need to know that this part is the node for Vx2. Alright, then let's solve this. Maybe you're going to apply nodal analysis. So you can put the current direction, and we have a reference point here. Alright. Okay, so we don't have any super node because this is 10. This is Vx1 node. So you can apply KCL at Vx1 node. And this is 10 minus Vx1 divided by 20 and plus 0.1 Vx1 and equal to, because this current is going out, so you have Vx1 minus 0 over 4. And since only one Vx1 unknown there, so you can just simplify this and you will get the answer. And you get the answer. Okay, for the step number 2, if you're going to apply mesh analysis here, you're going to have two equations, because when we have, if this is a current source, you're going to have a super node, a super mesh, sorry. And then there's another equation here, but because of here we have a current source, dependent current source here, so it will take the value, but you will have many more, yeah, you're going to have two equations, so it's better to use the nodal analysis. So in order to use nodal, you can give the current direction in any direction you like, and then apply the passive sign convention, and then you can get the answer. So the equation is reduced from 2, only 1 here. So over here you can simplify and you will get, and the Vx2 equal to 10. Oh. So you go back, return to your aim. The aim is to find Vx. So Vx1, which is equal to 2.5, plus Vx2 equal to 10, equal to 12.5 volt. So this is your final answer. Okay, I think with that, okay, thank you.